Welcome to Chapter 12.3, the square roots of quotients. For this lesson, you need to know two things. First is the power of a quotient law, which is something you need to know, or actually you just need to remember it because it is a law that you learned in Chapter 8. The law went like this, is that if we had the fraction xy and it was raised to an exponent, then you could rewrite that fraction as x to that exponent over y to that exponent. And obviously we used numbers a lot as well as letters. But if you also remember from this chapter that if a, or the exponent, is a half, then you could also apply that, which is x to the 1/2, y to the 1/2. Okay, so the fraction xy raised to the half power is x to the 1/2 over y to the 1/2. And you should also remember that the exponent 1/2 is equivalent to a radical, or taking the square root. So if we had the radical of x over y over the fraction xy, it's the same thing as the square root of x over the square root of y. If you use this with numbers, you could say that the square root of the fraction 3/2 is equivalent to the square root of 3 over the square root of 2. So in other words, the law allows us to express the square roots of many fractions as the quotients of square roots of integers. Now, this might not seem very significant to you, but if I can flip this page, we'll be able to show you. The second thing that you need to know in this chapter is that you don't want to leave a radical in the denominator. So while we can express the fraction 3/2 as the square root of 3 over the square root of 2, we can't leave it in this form. So instead, we're going to simplify the fraction by transforming the fraction into one whose denominator is a square. So if we had that fraction, 3/2, the square root of that fraction 3/2 could be multiplied by the square root of 2 over 2, which would give us the square root of 6, because 3 times 2 is 6, over the square root of 4, because 2 times 2 is 4. And since they're all under the radical, your answer remains under the radical. And of course, the square root of 4 is 2. So we're able to leave our fraction in this form, the square root of 6 over 2. Now, if you had the square root of a over b, you could multiply this by the square root of b over b, which gives you the square root of ab over the square root of b squared, or simply the square root of ab over b. Radical gone, problem solved. That is how you simplify a fraction. Okay, so some simplification is going to be easy. For instance, if you were given the square root of the fraction 7 over 9, you could see that that's very easily rewritten as this, and we know the square root of 9 is 3. Square root of 7 doesn't matter because it's in the numerator. So the only place that when we're simplifying and we can't have a radical, it's in the denominator. Okay, and some, of course, because what would algebra be without more difficult problems? Some are going to be more difficult. So if we had this problem, for instance, you would, think, okay, what can I multiply 12 by that will give me a perfect square? Now, obviously, you could multiply it by 12, but that would give you 144. And then you'd have this ginormous number up top, and you would end up having to reduce. So what you want is the smallest number that you can multiply 12 by that would give you a perfect square. And I think you would agree that that would be 3. So if we multiply by the square root of 3 over 3, we end up with the square root of 15 on top and the square root of 36 on the bottom. Okay, which equals the square root of 15 over 6. And while we could factor the square root of 15, we would just get 5 times 3, neither of which is a perfect square. So we can just leave it exactly in this form, the square root of 15 over 6. Now, if you have an even more, at least looking complicated number, okay, if we had the square root of the fraction 1 over 3x to the 5th, you can tell that we can multiply this one by 3, right? And then we also have to deal with this x to the 5th. Well, if we just multiply by the square root of 3x over 3x, we end up with the square root of 3x over the square root of 9x to the 6th, which equals the square root of 3x. Okay, the square root of 9 is 3. The square root of x to the 6th is x cubed. Because remember, when we're taking the square root of a variable, we simply divide its exponent by 2. And as long as it's an even number, we can pull it out. Okay, so the square half of 6 is 3. Okay, now sometime, let me just give you one little tip. If you have a variable in the denominator that doesn't have an even exponent, then you can't take the square root of it evenly. You would end up having leftovers, okay? But if you just multiply by the square root of that variable, okay? And remember, when you don't see an exponent, the variable is 1, or the exponent is 1, excuse me. So you end up with simply the square root of x on the top. Here you would have the square root of 4x to the 4th, because remember, we simply add the exponents. And we're going to end up with that square root of x on top. The square root of 4 is 2. The square root of x to the 4th is x squared, because we just divide that 4 by 2 in order to pull it out from the radical. So in other words, no matter what, if you had 7x to the 7th or x to the 19th, it doesn't matter how large the exponent is. If it is an odd number exponent, you simply multiply by the variable, because the exponent is 1, and now when you add them together, you end up with not positive, you end up with an even exponent, which is divisible by 2. And that's all you have to know to do this chapter. So go and have some fun.